If a cylinder goes in nicely with holes 1 and 5 and pins 1 and 5, then the pin index of that cylinder is 1,5. And if the pin index of a cylinder is 1,5, it has to be air, right? And if the pins are at positions 2 and 5 and the cylinders are having holes at 2 and 5, then the pin index of that cylinder is 2,5. And if the pin index of a cylinder is 2,5, it has to be oxygen. Similarly, if it is 3,5, it is nitrous oxide. So these are very, very specific for each of these gases. Okay, so it is a safety system which is present in your anesthesia machine, which ensures a right attachment of the gases. Okay, so you have understood the concept of pin index system. The second important challenge here is memorizing the different pin indexes of different gases we are using. I'm going to make your job easier. Okay, I'm going to give you a mnemonic. So please try to understand this mnemonic. Okay, so first write down AON 1, 2, 3. Okay, write down AON 1, 2, 3. So A is air, O is oxygen, N is nitrous oxide. Air has a pin index of 1,5. Oxygen has got a pin index of 2,5. Nitrous oxide has got a pin index of 3,5. Air, oxygen, nitrous oxide. Similarly, also remember C, 1, 2, 3. You remembered AON 1, 2, 3. Air is 1,5, oxygen is 2,5, and nitrous oxide is 3,5. Learning done. Now remember one more important code, C, 1, 2, 3. What is C? Carbon dioxide more than 7.5%. What is next C? Again, carbon dioxide less than 7.5%. And what is 3? Cyclopropane. Okay, what are the 3 C's? Carbon dioxide. See, whenever you are going to give the patient with carbon dioxide, it is never going to be pure carbon dioxide. It is going to be a mixture of carbon dioxide and some other gas, or say carbon dioxide and air. So what much percentage of carbon dioxide is present in that cylinder is also important. Some cylinders might contain carbon dioxide composition of more than 7.5%. Some might contain carbon dioxide less than 7.5%. So if carbon dioxide more than 7.5%, then it is 1. Carbon dioxide less than 7.5% is 2. And cyclopropane is 3. Now this is not 5. This is 6. So 1, 6, 2, 6, and 3, 6. Right? So AON 1, 2, 3. Then CCC 1, 2, 3. Air 1,5, oxygen 2,5, nitrous oxide 3,5, carbon dioxide more than 7.5%, more carbon dioxide, lesser value. Okay, so carbon dioxide more than 7.5%, 1, 6, carbon dioxide less than 7.5%, 2, 6, and cyclopropane 3, 6. We do have other gases as well. Like say we have a gas which is called as NOx. Okay, so what is NOx? NOx is 50% oxygen, 50% nitrous oxide. It is a mixture of oxygen and your nitrous oxide, and the pin index of NOx is very, very peculiar. It is 7. See, all other pin indexes were in 2 values. The only gas to have a single value as pin index is NOx, and the value is 7. Now here I mentioned that the openings and the indexes are present at these positions, and these are named like 1, 2, 3, 4, 5, 6. So where does your 7 come? 7 is a newer hole and newer pin, and that is present more or less at the center, and it is slightly larger than the other pins and holes. It is specifically only present for the NOx gas. It is 50% oxygen, 50% nitrogen, nitrous oxide, and that is this thing. Any other gas of relevance, question relevance? There is a gas which is called as nitrogen, not commonly used, but nitrogen has got a pin index of 1,4. You can remember that as well. Now, if you look at the recent INICET pattern, they always are asking the things which are commonly present in the operation theater, and nitrogen is not usually used in the oxygen theater. So these are the gases which are commonly used. And if you remember the first 6 values and the 6 values and NOx, probably you will not get a question in pin index or trying to ask a question from pin index from more than this. But just for further information, remember that nitrogen has got a pin index value of more than, pin index is 1,4 of nitrogen, right? So we have understood what is the significance of pin index system. It ensures safety of cylindrical attachment. Second thing is that you have different pin index values for different gases. That is what you need to remember. As a factual question, it can also come in your match the following question. Lastly, one more important question can come, concept-oriented question. What can lead to the failure of pin index system? Okay, so what can lead to the failure of your pin index system, or what are the factors, or what are the scenarios where your pin index system can actually fail? First cause, obviously, it works with the principle of broken holes. Sorry, it works with the principles of holes and pins. Imagine your pins are damaged, broken pins. Then that broken pin can go anywhere, right? So broken pin is something which leads to failure of your pin index system. What could be the second cause? Now, I told you this ensures that right cylinder is attached at the right place. Oxygen should be attached in the oxygen hanger yoke. Nitrous oxide should be attached in the nitrous oxide hanger yoke. That your pin index is going to do. But if you fill your oxygen cylinder with nitrous oxide gas and or vice versa, then your pin index system is literally not going to provide any safety. Right. The second reason of your pin index failure is wrong filling of gas. Wrong filling of gas. And there is one more reason why your pin index can fail, and let me just explain to you that. See here, see, this is your cylinder here, right? So this is your cylinder here, and you can see that I told you this is the nipple of the cylinder which ensures the gas flow from your cylinder into the anesthesia machine. Now these nipples are actually covered or protected with something which is called as washer. Now, what is the function of washer? Washer is just like a ring-like structure which ensures gas tight assembly, or it ensures there is no leakage of gas. This is a function of gas. Sometimes what can happen is these cylinders are always going to be very old. If you look at any operation theater in any government hospital or most private hospitals, we will be using cylinders for a very long period of time. And sometimes what can happen is the maintenance person might keep more than one washer in the nipple without knowing. So if there is multiple washer which is kept over the nipple, obviously there is going to be some relaxation. Some other pins can also go into certain other holes. So if multiple washers are being kept in your anesthesia machine cylinder or around your nipple, that can also lead to the failure of your pin index system. So what is the third cause of failure of your pin index system? Keeping multiple washers. Now, see, I've mentioned about the causes which could lead to the failure of pin index system. And how many points did I mention? I mentioned 3 points. And whenever anything has 3 points, always remember you can expect an all except question, right? And this was again a PGI question. So it can be considered as a previous year INICET question, yes or no? Yes. So this is all what you need to understand about pin index system, how pin index system works. Second point, what are the pin indexes of different gases? Thirdly, what are the factors which could lead to the failure of your pin index? Only 3 concepts in pin index system. Okay. And finally, I want to discuss the last concept, fact-based concept in your pin index, in your cylinders, and that is something which is called as cylinder color coding. Cylinder color coding. Pin index safety system is one safety feature that you have in your anesthesia machine. Second such feature is color coding of cylinders. By just looking at the cylinder, you should know what cylinder that is. It is very, very important, right? You might have filled oxygen cylinder with oxygen gas, but how do you identify that this is oxygen cylinder? So for identification of cylinders, it is very, very important that you have some color coding. Okay. Again, this is a very difficult thing to remember. I have some techniques in remembering this, but if it is useful for you, you can take that as well. Okay. So first of all, I'm going to give you the color of oxygen. Okay. Oxygen cylinder. The color of oxygen cylinder is black body with white shoulders. Black body with white shoulders. So you know that your cylinder will have a body and there will be a shoulder. The shoulder will be white and the body will be black. Now I'm going to give you a technique. If ever you are concerned about this particular gas called as oxygen, there will be some white in your cylinder. The shoulders will have some white if the gas that you have put in a cylinder consists of oxygen. Now the first gas is obviously oxygen. Oxygen has black body and white shoulders. Okay. Remember that point. I'll come to that again. You have another gas which is called as nitrous oxide. These two are the most commonly used in your anesthesia machine, and the highest probability of an image-based question can come from these two cylinders. Okay. So what is the color of your nitrous oxide? It is just blue. Nitrous oxide is just blue. It has got blue body, blue shoulders. Then I told you there is a gas which is called as NOx. Right? NOx is a mixture of nitrous oxide and oxygen. So it should have the component of nitrous oxide, it should have the component of oxygen as well. I told you if there is oxygen in the gas, there will be something white in your shoulders, right? Or so your NOx essentially has got a blue body and it has got either a purely white shoulder or sometimes it can have a blue plus white shoulder. So blue body with blue and white shoulder or blue body with white shoulder is NOx. Nitrous oxide is blue, oxygen is black body with white shoulders. Remember, if there is oxygen there, there is going to be some white. I'll give you one more example. Air. Right? Air consists of black body. Now, does air contain oxygen? It does contain oxygen, but it also consists of other gases. So it is not purely white shoulder. It is black body with black and white shoulders. Black body with black and white shoulders. Oxygen, black body with white shoulder. Air, black body with black and white shoulder. Nitrous oxide, blue body and blue shoulder. NOx, blue body with white and blue shoulders. Right? I want to give you one more gas, nitrogen. Okay. Nitrogen is just black. Similarly, one more gas that is called as cyclopropane. Cyclopropane. Cyclopropane is orange in color. Cyclopropane is orange in color. Now, if the gas has got helium in it, it will have some brown in it. So just remember it as brown, helium brown. Actually, the body and white and brown, everything alternates. But you just remember that if it is helium, it will have some brown in it. Now, what are the most important things that you should remember? You should remember about oxygen and nitrous oxide. Oxygen has been frequently asked as a fact question, as an image-based question. You can also get nitrous oxide question. You can also get NOx question. You can also get air question. These are the four ones with highest probability of an image-based question in your INICET exam, because this is what we commonly use in our operation theater. And as an intern or as a house surgeon or as a working doctor, you would have probably seen, or you should have probably seen, these four gases, right? So if you have not seen, I'm going to show the image here. So this is what gas? Can you tell me now? This is obviously oxygen, because you're going to have a black body with white shoulders. So this is oxygen cylinder. Please do remember. What are we seeing here? This is just a blue body. Yes or no? This is just a blue body, and that is nitrous oxide. This is nitrous oxide. What are we seeing here? We are seeing a blue body with white shoulders. So if it is blue body with white shoulders, it consists of nitrous oxide. And because there is white here, there is some oxygen as well. So this is NOx. I have not told you about this cylinder. This cylinder looks gray, right? So if the cylinder is gray, it is carbon dioxide. Now, where will you see this? You will see this in laparoscopic OTs, where they use carbon dioxide gas as an insufflator. So this could also be a probable question. Okay, so this is carbon dioxide gas, right? So let me just add that to our note here, right? Carbon dioxide is black. So I discussed a lot of factual questions from the topic called as your cylinders. I discussed about pin index system. I discussed about your particular color coding as well. And that will cover all the MCQs which can come out of your oxygen cylinders for your INICET exam. Now let me take you back to the question. Match the following correctly. Cyclopropane is what? What is the pin index of cyclopropane? Remember C. It is a third C and it is 3,6, right? So cyclopropane A is actually joining with B. So where do you have A and B? I have B and C option. So I have here, it can either be B or it can either be C. Now what is carbon dioxide more than 7.5 percentage? If carbon dioxide is more than 7.5 percentage, then your pin index is going to be 1, right? So B is matching with C. So A, B is matching and B, C is matching. And what is air? AON 1, 2, 3. A is 1, 5. So C is A. So what is the correct answer to this question? A, B, B, C, C, A. I hope you have got a very good basis in anesthesia cylinder. So we have discussed the high pressure system already. Tomorrow onwards, I'll be discussing some factual questions which might come from intermediate pressure system and low pressure system. Thus, I have covered a whole chapter for you of your entrance exam. It is a very, very difficult chapter which is called as anesthesia machine. So I'll come again tomorrow with a new question on intermediate pressure system. Right? Thank you.
Recording stopped.